So in this one, I'm going to show you what happens when we are dealing with functions in the complex plane. So imagine that we have here f of z and say that it's equal to 2z. What we want to try to do is to understand what a transformation this applies. So imagine that here I have the following. This is the real axis, and then imagine this is the imaginary axis. And imagine that here I have pretty much something resembling a square as much as possible. Let's label the coordinates. So like this would be 1 plus I over here. Say this is 2 plus I, so I'm just changing the horizontal. I'm going to go up, say, to this point. What will that be? Well, let's see. 2 plus 2i, because you got to change the I part. And then over here, let's see. I'm going to call this A, call this B, call this C. So point D, let's see, I'm going to label that as 1 plus 2i. And what I really want to do is understand what happens when I feed this square into this function. What does its image look like? That's the goal here, okay? Keep that in mind. So I'm just going to find the images of the points by plugging them into the function. So 1 plus I, what's the image of that? It's 2 times that. So that would be, let's see here, 2. And then 1 plus I, which is 2 plus 2i, you see? Next. So that basically, I'm going to call this point A prime. Then after that, let's do f of, let's see here, 2 plus I. That's going to give me 2 times 2 plus I. But that's just 4 plus 2i. I'm going to call this point B prime so I can mark it. Next one, f of, say, 2 plus 2i. That's going to give me 2 times 2 plus I, rather, right here. And when I do that, it's going to give me 4 plus 2i. So 2 times 2 is 4, 2 times I is 2i. That's also the last part, so it's going to be f of, let's see, 1 plus 2i. So it's going to be 2 times 1 plus 2i. That's going to be here 2 plus 4i. This is going to be d prime. Pictures. So first of all, you have to keep something in mind that like this point here, a prime, is 2 plus 2i. Our original point back here was a 1 plus I. So if I keep that same distance, I have to be really careful about the way I measure things. Like, for example, this would be twice as far this way for a prime and then twice as far vertically, for example, you see? So maybe say it's over here. Okay, so this is 2 plus 2i. This is a prime, basically. Look at point B prime. It's 4 plus 2i. Okay, so again, I have to be really careful. Like if this is 2, right? This is 2 for the real part. And then I have to go over where it says for B prime right here. I have to go over 4. So this is 2, 3, 4. Basically this right here, see? The base here has to be twice as wide as this one. So if this one is 1 unit, then this one has to be 2 units, basically. Just keep that in mind, okay? So this is going to be B prime equal to, let's see, 4 plus 2i. Okay, doing it freehand, that's why it looks a little bit rough. Okay, then same thing with this dimension, this vertical dimension. That's C prime up here, which is 4 plus 2i. Again, this has to be twice this vertical side in the original shape. Why is it twice? Because if you look at it, right, what does the 2 do here, and then here, and then here, and then here? When you multiply by 2, you're stretching everything by 2, you see? That's all it is. Okay, over here, I'm going to have now the point D prime. So that's, let's see, what's D prime? So this is 2 plus 4i. So again, that means this piece here is now twice that piece. And then this here is twice after the image is put here. That's what I meant to say. Why is it happening this way? Remember, this is the real axis. This is the imaginary axis. So we have basically a square in this space. We'll call this Z space, and imagine that W is the output. So in W space, we also have a square, but everything has been enlarged by a factor of 2. And the reason is, look, f prime of Z is 2, and that's it, right? If f is the original function as 2z, then f prime is 2, which means this 2 right here, it basically stretches every side by 2. That is a direct action of the derivative. That's all it's doing. And that's pretty much it. So thank you so much for watching. Please leave a like and subscribe. I will see you in another video.